So here we're going to simplify radicals of monomial expressions. So we're going to have coefficients, we're going to have variables, exponents, everything we got. So the first thing we want to do when we see this is you can actually combine or separate the radicals if there's multiplication or division. So we want to do that first. So we're going to write this as negative radical 80 a to the 6th power and b to the 11th power. And each of those pieces are going to get their own separate radical. For coefficients, so that 80, we are looking to simplify using perfect squares. And for those exponents, we had that very basic rule of the exponent divided by the index. So I'm going to do these on the side separate. So the square root of 80, I did a video on this explaining different methods. I like using perfect squares. 80 you can write as radical 4 times radical 20, and 4 is a perfect square. The reason I don't like using these factors is because 20 can also divide 4, so you're going to have to do more work. 80 is actually 16 times 5. 16 is a larger perfect square, so that's the number that we're going to use. The square root of 16 is 4. So we get 4 radical 5. And that's just simplifying the radical 80. Has nothing to do with the rest. A to the 6th power, because these are square roots, 6 divided by 2 is 3, so we get a to the 3rd. Now, b to the 11th power, when we do 11 divided by 2, that's not going to give us a whole number. So similarly, we are going to find a perfect root under here. If our index is 2, our perfect roots have to be even exponents. So I can rewrite b to the 11th as b to the 10th, which is even, times b to the 1st. The square root of b to the 10th, that is a perfect square. That's b to the 5th power. Then I have this leftover b there. So that simplifies as b to the 5th radical b. One problem split up into 3 separate radicals, all simplified on their own, and now we have to put them all together. So outside the radical, we're going to have negative 4, a to the 3rd, b to the 5th. Inside the radical, we're going to have 5b. And that's how you would simplify these monomial expressions within the radical. So we'll do another one. That's division. That can look complicated, but we're going to go through the same process. So we have division here. It's a 4th root. The first thing I notice is that if we have a fraction and we have a's in numerator and denominator and b's, I want to combine this first as much as I can. So I'm actually going to divide these pieces. So 240 divided by 3 is 80. A to the 14th divided by a squared is a to the 12th. And then b to the 6th divided by b to the 6th is b to the 0, which is 1. So I actually don't even need to write that. So now we're doing 4th roots. The 4th root of 80 times the 4th root of a to the 12th. Well, a to the 12th is going to simplify. 12 divided by 4 is 3, so that's going to be a to the 3rd. Now the 4th root of 80, I'm looking for a 4th root. So I need to know my perfect fourths. I'm just going to start with 2 to the 4th power. 2 times 2 times 2 times 2. 4 times 4 is 16. 16 is actually a factor of 80. The fourth root of 16 is 2. So that's how we would simplify the radical 80. So we'd have 2 and the fourth root of 5. So your answer, once you divide, split these up and simplify each one, is going to be 2a to the third power, and then it's the fourth root of 5. So that's how you simplify those radicals with the exponents and everything else.